So these are Unit 8 sample and practice problems. I'm going to do 1 and 2. You're on your own to do 3 and 4. The equations we're going to be using are listed on your worksheet. So please refer to those as needed and make sure they're on your equation page for using for later. All right. So light coming from a star is measured at 400 nanometers. Remember, nano is 10 to the negative ninth. And we know that one is 400 nanometers. That's the one we measured. And then we know that the actual value should be 395. So that's the real one. And we want to figure out how fast it's going. Fast is velocity, and nanometers is lambda. So in my given, we have the lambda measured is equal to 400 times 10 to the negative ninth meters. And then we have the other one, which we're going to call R for real, which is 395 times 10 to the negative ninth meters. And then we always know the speed of light, which is 3 times 10 to the eighth meters per second. And our unknown is how fast is it going, so that's V. And if I look on my paper, I can see that V is equal to lambda real minus lambda measured over lambda real times C, times the speed of light. So when I solve, it's actually the same exact thing in this case because there's nothing to solve for. Lambda real minus lambda measured over lambda real times C. I'm running out of space, so let me move this up. Okay. So then when I actually find my solution, it's going to be the difference between the two. So 400 times 10 to the negative ninth meters minus 300. And it really doesn't matter which way it's off. It's important for one thing and one thing only. And that is all divided by what the real one is, which is 395 times 10 to the negative ninth meters. And then, I'm obviously running out of space, times 3 times 10 to the eighth meters per second. My goodness, such big numbers, right? And so when I'm calculating, I notice that the 10 to the negative ninths all cancel, and so I'm just left with 400 minus 395, so that's going to be 5 divided by 395, right? So the math really isn't that bad once you figure out what you're doing. So my V is going to be, again, the 5 on the top over 395 on the bottom, because, oops, times. Let's fix that, hang on. Again. And so we have V is equal to 5 over 395. The units all go away too, right? Because meters all cancel. So that was 400 minus 395. That gave me 5 and 395 on the bottom. And then times 3 times 10 to the 8th meters per second. So if I do the calculation, I end up with V is equal to about 0.013, the speed of light. 3 times 10 to the 8th. And I'm rounding, right? And that comes out to be about 3.8 times 10 to the 6 meters per second. Now, the second part of this question, I know it makes it kind of funny, says, in which direction is it moving and how do you know? And I notice that the measured one is a bigger lambda, so that must mean, bring that here, let's see if we can bring, okay, we'll scoot this over. And so since lambda measured is greater than lambda real, right? So this one's bigger. That means that it's red shifted. And since it's red shifted, because remember, red has a higher wavelength than blue, that means that it's moving away. So it's moving away from us. And the reason you know that is because the lambda is bigger. Yeah? A lot of concepts, one question. Okay, so let's do the next one. And it says, according to this graph, what is the Hubble constant? Now, all the graphs I found, it was so hard to read the numbers. So what I did was I gave you one. They always go through 0, 0, right? We always go through 0, 0. So we have 0, 0 down here. But this one up here is the other point that we need. So in my given, I can see that V is equal to 1,000 kilometers per second. And my distance R, remember R's distance is 2 megaparsecs, which is about 3 light years, a little over 3¼ light years. And my unknown is the Hubble constant, which is h naught. And my equation is V equals h naught times R. I want to be able to find h naught, so I divide both sides by R, and the R cancels. So I'm left with h naught equals V over R. Come over here. So when I solve it, h naught is equal to 1,000 kilometers per second all over 2 megaparsecs. So 1,000 divided by 2 is 500. And it's 500 kilometers per second per megaparsec. Okay? So that's a 500. Really it is. 500. Let's make that look a little nicer so we can read it. So that is 500 kilometers per second per megaparsec. Right? So there are the two. You do your own and see how you do.